All right. Hello, everyone. Thank you so much for waiting. We appreciate your patience, and I think that without further ado, we can start. We're thrilled to have you here with us today for a live webinar about how FreeTV builds secure, reliable streaming. My name is Yoav Marcus, and I'll be your moderator for today's session. So whether you're dialing in from the UK, Europe, or elsewhere, thank you for taking your time to be with us today. And over the next hour, we are going to take you inside the journey of FreeTV. As you probably know, you will find out how this multi-channel streaming platform overcame two key challenges, which are achieving reliability and performance for broadcast and VOD transmissions and securing their cloud environment. You'll then hear from AWS and our Automat-it expert on how they designed and implemented the solution using CloudFront, multi-account networking, firewalls, and Direct Connect. Unfortunately, as you probably can see, due to urgent personal matters, Haim Zohar, the original FreeTV speaker, was unable to be present today, but he asked to convey his sincere apology. However, I'm sorry, I will be happy to introduce you to our additional speaker on behalf of FreeTV. So our experts for today are Boaz Levenstein, Senior IT Manager at FreeTV. Hello, Boaz.
Hello.
Also, just to let you know, Boaz will need to drop after he presenting his part, but you will be able to ask him questions. So make sure that on the dedicated Q&A field, you will type your questions for Boaz, because immediately after he's finishing his part, he will answer questions in case there will be any. Right after is Yossi Chai. Hello, Yossi.
Hi, folks.
Thank you so much. Thank you for joining us. So Yossi is Senior Solution Architect at AWS. And last but not least is Oleksiy Bebich. Hi, Oleksiy.
Hello.
Thank you also for joining us today. Oleksiy is Automated DevOps expert plus official AWS ambassador. So right before we'll kick off and start with the actual interesting professional part of this webinar, please allow me to remind you that the session is recorded for the sake of sharing it with you and the other registrants who couldn't join us today. Also, it's important to let you know that we will leave time for questions also for Yossi and for Oleksiy immediately after their sessions, meaning more towards the end of the webinar. So get your questions ready and type them only in the dedicated Q&A field, which you can see at the bottom, not in the chat. Plus, we really recommend you to stay engaged and type your most eager questions, since we will share 5 AWS credits for the most 5 original questions to be asked. And finally, as I was already been asked by one of the attendees, is that we'll be raffling off a $100 amazing Amazon gift card. I'm sorry, to one lucky attendee. So stay tuned till the end of the webinar. And now, without further ado, over to you, Boaz.
Okay, so hello, everyone. My name is Boaz Levenstein, as we said, and I'm heading the IT and operations here in FreeTV. And let's start with a small introduction to who is FreeTV. So at a glance, FreeTV is the newcomer Israeli broadcasting TV solution. We are already giving our service to our customers for 2 years, and we reached approximately 160,000 customers in just 2 years. We stream into any device, anywhere here in Israel. And when I'm saying to any device, it's actually any device. We don't need any perpetual devices at home. We have application, which could be used on any TV, any smart TV, and of course on any streaming device, even if it's Android, Apple, whatever. The customer can install our application and stream our content. Our content is roughly 60 channels, all major Israeli broadcasters, and many, many other more. Plus, we are giving very, very big VOD library that the customer can play at any time, whenever they like, to choose whatever they want to play and see their desired content. As a company itself, FreeTV is a very, very, very agile company. We are very, very, very low on resources. and also on headcounts. The entire company is less than 50 headcount. The entire company, including technology, service, whatever. The main thing that we do here in FreeTV is we're giving our service using many other companies. Some of them are Automate, AWS, and many other more that helping us to give the best solution to our customers. And as I said, and as you can imagine, FreeTV is fully cloud company. All of our infrastructure resides on the cloud. We use AWS for this, and we don't have any other on-site or on-prem infrastructure. Saying that, we have very few of them, and we'll talk about it a little bit when we continue. But most, like 95% of our infrastructure is residing on AWS. So how do we do it? In order to stream the video from our broadcasters into the network, our solution is doing like this. We are encoding the video on the site. We have many broadcasters, as we said earlier, about 60 channels. Some of them we need to encode on site and move them to the network. And for this, we use Direct Connect because all of our infrastructure, as I said, is on Amazon. So what we are doing, we have several broadcasters which we connected directly to Amazon. Then we encode the data, stream it to Amazon, and from there move it into our origins inside Amazon. Afterwards, when we want to bring this content into the customer, we use, of course, the CloudFront. For this, we use for both the live broadcast and the VOD. The reason we are using CloudFront is because CloudFront have a very big POPs here in Israel. They have 2 POPs connected into all major Israeli ISPs. This is enabling us to give the best performance to our customers, very low latency, and very good performance. Furthermore, since Amazon is widely spread in Israel, it's also fault tolerated. So if one POP is having connectivity issues to one ISP, we can serve it from the other POP. Furthermore, we have many other applications that need to be installed on Amazon. Some of them are the service applications, the customer applications like CRM, billing solutions, and many other more. We also use Amazon for this, and we're using many services like EKS for Kubernetes, and of course, regular instances. We're using, again, the multi-availability zone of Amazon, giving us resilience and security. And we also use other solutions and other partners also in Amazon, like Palo Alto, to give us security, firewalls, and VPN to access the network inside Amazon. Of course, the system itself is elastic. We can enlarge it, add instances, and scale up the Kubernetes in case of need or high load, giving our customers, again, very good service at all time. Since television is being watched 24/7, we cannot afford even 1 minute of downtime. This scalability and resilience give us the solution to give the customers the best performance at all time, anytime and any day, 365 days at the year. To conclude everything, being cloud company, FreeTV can serve a very large user base, giving high-end product and competitive price, with very low internal footprint. So we are very resilient. We're super secured. Everything is secured because we use WAF in front of the CloudFront and load balancers. Everything behind it. It's private. It cannot be accessed from the network, only what we want to serve. And it's very, very, very scalable. We can scale it if we have high loads. We have some very, very big broadcasters and events giving us thousands of online customers. And the system is elastic, so we can enlarge the system as customers are accessing the system. We had several occasions that we actually almost doubled the capacity of the system without any issue. One more very, very important thing is that we have numerous assets that we need to store on the system, approximately 200 terabytes, that we can put it on Amazon infrastructure without the need to hold very, very big data centers ourselves. If you will take a look at FreeTV in comparison to our competitors, you will see that our competitors, with approximately same user base, holds enormous data centers here in Israel with a very, very, very large footprint. They need many employees to handle this operation, while we have very, very thin operations due to this way that we are doing and implementing our solution. So we are very, very, very lean and mean company, giving our service to numerous amounts of customers with the help, of course, of AWS and Automate to give it a very, very low footprint with great resilience and super, super, super adaptive solution. Thank you, guys.
All right, boss. Thank you so much.
Questions?
Yeah, so we do have, I saw one question. I think that, oh, there's another one. Okay, so let's start with, I hope I pronounce the name well, with Werner. Hello, the on-prem encoding. Could you elaborate a little more, please? How do you receive the contributions? What solution do you use for the encoding? Are you already encoding the final ABR profile on-premise or to a median level and in the cloud encode the ABR profiles? It's a long question. Let me know if you...
No, it's a great question. So the
Okay.
entire encoding we do in on-prem. We put the encoder on the site itself because we want to move forward only the final encoded data, and we move it from after we encode everything. We have a center. We have one very big POP ourselves because we don't have we need to put all the specific hardware to encode the stream. We encode it and then move it to Amazon using, of course, direct connect. We have very, very big lines connected to Amazon. Actually, we have currently also in order to get redundancy and resilience, we have 4 lines into 2 major POPs of Amazon here in Israel, going from our main video processing central into Amazon itself. This is the only on-prem solution that we have here in Israel. It's the encoders themselves.
All right. Thank you, Boaz. Next question is from Pablo. Please describe how live streaming component works exactly. What components, aka services, I assume, are there and how they interact? How much does it cost to support streaming or VOD for one user during month on average?
So, of course, I'm not going to get into specific costs, but just as I said, we have a multi-layer solution, actually. We have encoders on the broadcaster sites themselves. Then we move to the encoded data into main final encoding solution that we do another encoding. And then we move the final assets, encoded assets, into the origin. The streaming itself, we're doing live encoding and move it directly into the origin to the CloudFront origin. So it's a little bit different if it's live again and a VOD as Pablo asked, because stream, we just encode it and move the encoded data directly into the origin itself to serve it to the customers.
All right. Thank you very much, Boaz. Next question is from Andre. I really enjoyed your presentation. Are your clients widely spread across the globe or mostly in Israel? Plus, what add-ons technical solutions do you use to ensure your clients have the best experience on any device? And also, you mentioned the 100% SLA for your clients. How do you manage to achieve that, especially regarding disaster recovery and high availability for your backend services? Do you use AI to ensure the client's best experiences?
So I'll start answering one by one. First, to ensure best performance to our customers, currently we're using some solutions that most of the people in the industry knows, like MOOCs and nice people at work, to get the client performance themselves. We then aggregate everything and analyzing the data to see if we have some customers that have some issues from specific devices or maybe from specific ISP. We sometimes see that there is a specific ISP with some issues, and then we can approach this ISP and see why this degradation of service is occurring, and give the best solution working with this ISP. We had some issues when we begin to work, that we saw some issues with specific small ISPs here in Israel. And of course, we could achieve a solution with these ISPs. And today we see that most customers getting very, very good performance and a good experience. It's another thing to mention, as you asked, that the entire service is here in Israel. We have very, very few viewers abroad. This is mostly due to regulations and regulations, and that we cannot broadcast everything in abroad. So we broadcast almost everything here in Israel. Regarding AI, this is something that we are just now starting to get into, to aggregate data. When we speak in AI, the main issue achieving good AI solution is having very, very vast data, and across we need many data points. Now that we are already 2 years in service, it's starting to get to be more interesting, and we have enough data to start analyzing, putting into AI models to give us a better view of one, what the customer will want to watch in the future, and B, to try to predict some issues of customers. This is the main thing that we have started to work with the AI.
All right, thank you, Boaz. Now, since we don't have a lot of time, because we have 2 more presentations and a Q&A also for Yossi and for Alexei, I'm going to read only 2 more questions, and they are both from other people that they didn't ask so far, because we had more questions from people who already asked questions. Don't worry, all of the questions will be checked after the webinar. Do not worry in terms of the AWS credits. So next question is from Vlad. What was the
Primary
cloud benefit that made you almost abandon data centers?
So the main and the primary benefit moving into cloud is superior when we worked in traditional on-prem companies. We need to hold very, very big data centers and numerous amounts of employees, and maintaining these the infrastructure and the employees, it's very, very, very high maintenance to a company, because to manage everything, the company needs to be very, very big. If you've taken a FreeTV and put it versus the same company, putting everything on-prem, you will see that the competitive company is about 10 times bigger on manpower and assets, and this is something that you need to maintain. And it's very, very hard to maintain it. And you have numerous amounts of issues, because you can never get the best of breed when you move into Amazon, since it's so big, you get most best-of-breed solutions, and it can give you the SLA that you want to get, the 99 plus 99% of uptime, giving you with lower footprint and enormously lower budget. This is the main advantage of moving into the cloud.
Very well, thank you. And last question is from Jan. Given the AWS outage recently, what does the R look like, and how do you keep a track on costs from a FinOps point of view?
So definitely the outage that AWS had almost 2 weeks ago, it was very, very, very disturbing, I would say. Currently, I must admit that we're just using availability zones on the same region. So if we're gonna have the same issue like Amazon having in the region, in the US East 1 on our region, we would be suffering from downtime, and we started to think to expand into multi-regional solution. Saying that, I must say that eventually no one is lacking. Always malfunctions will always eventually happen, and we need to learn and to move forward. So right now we are thinking about moving into multi-region solution. And saying that, I must say that looking at other, again, at the competitors that we have, they are not lacking of malfunctions. So this is also something that we need to take under consideration, because eventually malfunctions will happen.
Boaz, thank you so much.
Thank you
for your presentation, for your time, for answering the questions. Great questions, by the way. Keep asking them, keep typing. So Boaz, if you'll need to drop,
yes, I'll stay. I have 3 more minutes, and then I have to drop.
Perfect. So I'll just gonna ask you to stop sharing your presentation in order for
Yes.
Yossi to speak and share his. And thank you so much.
Thank you, Yoav.
All right. Thank you, Boaz. Can you see my screen?
Yes.
Yes.
Right. So hi, everyone. My name is Yossi Chai, or Yossi Chai, if you want it in English. I'm a senior solution architect at Amazon Services, Amazon Web Services, and I'm really excited to meet you all today and to talk to you about content delivery and scale. Boaz mentioned it a little bit, and I hope I will be, we will a little bit deeper dive into it. So when there are some fundamentals of internet-facing applications that are simply required today, right? When you are doing broadcasting, they need to be performant, secure, and reliable. With this goal in mind, there is one AWS service that helps with all these requirements. In the presentation today, I'm going to talk about which AWS services you should be using to make your application performant, secure, and reliable, while showing you how to reduce your data transfer bills on AWS. So we're talking about Amazon CloudFront that can help with all of these goals that I've mentioned. So reducing, and I will go one by one on them, reducing latency and improving security by encrypting traffic and moving it along the AWS network, delivering application data through a worldwide network of data centers called edge locations, protecting your web resources against DDoS attacks with services like Shield and WAF. More about WAF later. Customizing application behaviors by routing around the unhealthy endpoints. People talked here about what happens if something goes wrong, and something definitely will go wrong. So we have the capability of moving unhealthy endpoint transparently and using built-in CloudFront features, or by customizing requests or responses through the edge computing function that integrate with CloudFront. CloudFront is even a great way to optimize your application cost by offloading delivery of static assets to CloudFront cache, reducing load on origin servers, and hence also reduce cost by needing more servers to serve everything. So how does it look? We have a global footprint which growing by 33% year over year. This is how it looks like. Basically, we have CloudFront has a large global network with over 700 edge locations near population centers globally, and as I said, increasing year over year, and 13 regional edge cache centers that back them up. All of our edge locations are connected over a redundant private backbone to AWS regions. This means that CloudFront can accelerate application of all types, static assets like images, video files, CSS files, JavaScript, can be cached in edge locations and deliver closer to the end users, while dynamic requests that need to go back to the application origin are accelerated over AWS global backbone network. So little bit diving deep here, showing some how the architecture looks under the hood. As you can see in this diagram from maybe left to right, we have two layers of content caches. Okay, so upon a user client request, it will be routed via Route 53 to the nearest available edge location. Nearest can be in terms of latency and availability. In this case, we have other ways to route traffic, but this is what was chosen here, which will be then checked, of course, by AWS Shield automatically. AWS Shield, just in a nutshell, is a layer 2 to 4 DDoS protection. Okay, so against TCP floods, UDP floods, and so on. So this is the layer that it protects. And the WAF, which I will mention even in detail later on, protects the layer, the seventh layer, the web application layer. And if those checks are passes, then CloudFront will receive it. And then, of course, we are trying to see if we have a hit, right, in the cache. So in case we have a cache miss, and we don't have it in the CloudFront edge, okay, the request will be routed to the CloudFront, one of the CloudFront regional edge caches, which is, of course, larger, has more capacity. And only if we don't have this kind of content in the regional cache, we will then forward the request to the origin itself, either if the origin is hosted on AWS, it can be a S3 bucket or EC2, and it will be rerouted via the AWS network here in green, or of course, going to the on-prem to the customer data center if needed, if the origin is hosted there. So this is maybe the time to mention that CloudFront can protect your origin servers even if they do not run on the cloud. So it's a really powerful tool to use in terms of security and performance acceleration tool. So CloudFront can, a little bit about CloudFront integration. It can integrate with AWS WAF, as you can see here, and Shield to improve your security and block malicious traffic at the edge. WAF can even be turned on through one click. You can use one-click integration with CloudFront. So it makes it very, very easy to secure your application. And in addition, you can see here, that CloudFront can be let's call it some kind of facade even for your API gateways, elastic load balancers, and of course S3 bucket if you want to deliver some kind of a single page website. More about CloudFront. CloudFront have also some computing capabilities. So it brings its intelligence to the edge using some edge computing, we call it. Both CloudFront Function and Lambda at Edge, we have two types of services, are great. There are great edge computing options that integrate seamlessly with CloudFront. CloudFront Function runs in every edge location, and they're short-lived JavaScript functions, about 1 millisecond, by the way, that can do things like request normalization, origin selection, and token validation. While Lambda at Edge are more longer running scripts that operate in regional edge caches and have full access to things like network codes, integration with other AWS services, and more. Using these two things together give you the ability to customize the request for every user and need. You can see it here as well. So CloudFront is the easiest way to cost optimize. We talked about a little bit how we can reduce the data transfer out, as we call it, DTO cost. There are a few important things to remember. CloudFront does not double charges for your data transfer. That transfer from your application origin in AWS to CloudFront is free. You're only charged for the data transfers from AWS and outward, I mean, from the CloudFront outward. So adding CloudFront will not increase your traffic bill. On the contrary, it will reduce it because we have better tariffs on CloudFront DTO than for example, from load balancing, elastic load balancing. There are easy ways to get further discount on data transfer charges, like if you're adding CloudFront security service button, so you can get a 30% discount. And if you use higher traffic usage, more than terabytes, you can also ask for a PPA, private pricing agreement. That's why the prices vary between customers. And maybe I haven't mentioned it, but for the first terabyte each month, it's actually a free tier in CloudFront, so you can use it to test whatever you need and to see if it suits your needs. So maybe last but not least on CloudFront, we all talked about streaming today, and Boaz mentioned FreeTV and what they're doing, but we are working. I wanted to bring some other customer reference as well in this area of broadcast streaming. So this slide really speaks to the scale that CloudFront can achieve. Events like Super Bowl are real testament to CloudFront's ability to serve major customers. You can see the Paris Olympics, what that was broadcasting, and of course, the NFL league and so on. So without further ado, let's talk a little bit about how we protect CloudFront with the web application firewall. Okay. So what is AWF? Or in short, WAF? It covers the application layer, as I mentioned earlier, or the layer 7 or in the OSI model. It's meant to protect the business logic. Okay, I mean, instead maybe shield that protects us from hacks, floods, and so on in the lower levels. Once we have our HTTP connection established, then it's a different game. We're going to the application layer, and then we need other tools to protect us from DDoS attacks. You can use WAF to temporarily patch vulnerabilities, by the way, without having to make major code changes. It can block malicious actors from coming in, or it can filter out incoming requests, and of course, reduce the threat vectors overall. One thing to stress out here is that AWS WAF is a tool that you can supplement to your existing security posture, but it's not meant to replace all of it. Was mentioned, I think, earlier on that they're using Palo Alto firewalls to do further of course, test and protect their system. So as we know, security is a very complex area. So we need a couple of measurements to have a good security postures. But WAF is definitely one of them. So benefits of WAF, and I will run very fast on them. Frictionless setup, already mentioned. One-click deployment when using CloudFront. You don't need to configure SSL or change your DNS of your CloudFront. So it's quite transparent in the way it works. Low operation overhead. Ready to use CloudFormation templates with built-in SQL injection and the cross-site script exploit detection and manage rules through AWS Marketplace. I will talk about it later on as well. Customable security. Highly flexible rule engine that can inspect any part of the incoming request under a single millisecond latency. And last but not least, advanced automation with API-driven architecture and fast rule propagation allow you to detect and respond to a threat in real time. So where can we deploy WAF? So we already know about CloudFront, but we can deploy WAF even if we're not using CloudFront. We can deploy it on our application load balancer. So we made it, maybe in general, we made it easy, of course, to deploy it, as there is no need to reverse proxy or DNS setup or TLS certification. You can enable it at the edge through CloudFront, as we mentioned, and you can put it directly on your ALB at the regional level. And if you're using serverless architecture or microservices, you can use also API gateway and protect it as well. And of course, you can have different WAF setups on different. If you're using both, let's say, CloudFront and load balancer, you might need to, or you might want to protect them differently, or see or check different rules on each and every one of them. I wanted to put here how a small diagram or how a look. Let's call it manage groups looks like. You can enable and disable each rule. Several reinvents ago, we launched AWS managed rules to help you to get started quickly and easily with the AWS WAF. We understand that not everybody is a security expert. So the idea behind the managed rules is that we would cover the common attacks vectors, so you don't need to spend a lot of time managing basic sets of rules. Thus provisioning you providing you with a stable baseline to work with. These rules are managed by our threat research team, which is an extension to our DDoS response team. I don't know how many of you are familiar with our DDoS response team, which is another service that's highly recommended for a highly production environment to have. And they're being providing from our AWS Shield Advanced team. So the rules are influenced by the top 10 security risk identified by OWASP community, and are being, of course, updated from time to time as needed. And again, it's important to stress that all WAF in general cannot offer you full protection against all attack vectors in the top 10 list. Hence, we need other tools as well. AWS, maybe last but not least here, AWS managed rules are available at no extra charge for you. Last thing about managed rules from AWS Marketplace. So on top of our managed rules and the ability for you to write your own custom rules, we are offering, of course, the AWS provides rules managed by security experts via AWS Marketplace, like F5, Shell Micro, Fortinet, Imperva, and so on. You can choose your protections, bundles, packages, buy them and deploy them easily, and even get automatic, of course, updates on those who once you subscribe to them if needed. Yeah, I think I covered that up. So maybe the last thing on this topic. Just a second. If you want to learn more about CloudFront and the application security measurements, or even test your knowledge and skills, I've put here a couple of links to resources which you may find useful, and Yoav will share them with you later on after this session. Thank you.
Thank you, Yossi. That was really insightful and interesting. Thank you very much. And I think that we'll have exactly time to allow Alexei to come on stage and share his screen, his presentation.
Oh, yeah. Let's start. Hi, everyone. My name is Alexei. I'm DevOps expert and AWS ambassador from Automat-it. And today I will share how we build secure, reliable, and high-performance streaming platform for FreeTV using AWS services. And this project combined multi-account design, hybrid networking, caching, and security built by Automat-it team to deliver seamless live and on-demand streaming at scale. And a couple of words about me. I have 12 years of experience in IT. Working at Automat-it since 2020, started as DevOps team lead. And for the last 2 years, I'm AWS expert in Cloud Center of Excellence in Automat-it. I'm also an AWS ambassador, community builder, fully AWS certified, and I actively participated in the project when we built infrastructure for FreeTV. And overall, I help organizations modernize and scale their cloud architectures with AWS best practices. And our agenda for today, quick look at AWS organization structure, how we use landing zone to isolate workloads on the account level. Then we will look at multi-account networking with Palo Alto firewalls, CloudFront and WAF for FreeTV applications, and high performance and resiliency for hybrid infrastructure, as Boaz previously told us that we have some part on premises. And everything starts with a strong multi-account strategy. FreeTV environment runs on AWS landing zone, built with helps of Cloud Control Tower. And every account has a clear single responsibility. So we have dedicated accounts for logging, for security services, for centralized networking, and for every single workload. And this separation ensures blast radius reduction. So if one of environments is compromised, others remain safe. Billing transparency. Each workload is isolated for FinOps reporting. And policy enforcement using service control policies and AWS config to ensure compliance. And in FreeTV case, security is critical and includes many components. But today we focus on networking. And in our case, network account acts as a central hub with shared transit gateway and other networking related services and tools. And this is more detailed schema of networking account and how we interconnect different workloads through it. So networking account has a shared transit gateway, and all other accounts, VPCs, are connected to this transit gateway. We have two different VPCs inside the networking account. One VPC is responsible for firewalls. Here we have Palo Alto firewalls deployed in different availability zones behind the gateway load balancer. We have a solution called Palo Alto Panorama for centralized management and synchronizing firewall rules between different firewall nodes. We have another Palo Alto solution called Global Protect VPN. It works like OpenVPN, but with more features from Palo Alto. So in general, it's used for engineering teams to have private connectivity to the isolated private networks. Network account also contains Amazon VPC IPAM service to allocate CIDR blocks for new VPCs and avoid CIDR range overlaps. We have network orchestration for transit gateway. It is open source solution developed and maintained by AWS, available on GitHub. And this automation is needed to automatically connect a newly created VPC to our central transit gateway and propagate appropriate routes to the subnets, VPC subnets. And network account also a point where we terminate our connections from on-prem, especially direct connect and site-to-site VPN. And we also have shared services account where we have AWS directory service, which is used for SSO to AWS accounts and for this Global Protect VPN. And as a result, Global Protect VPN allows us to provide different teams with different routes, especially to the networks where they need to have access to. For example, application 1 team during the connection to VPN receives routes only to the appropriate application 1 VPC. The same with another team. And firewalls are used to filter all traffic originating from VPCs. It's north-south traffic from AWS to internet. It goes through firewalls. And the same as if different VPCs need connectivity with each other, they also goes through the firewall, analyzed, and if allowed, okay, fine, connectivity is established. And this is more detailed schema of how traffic actually goes through the firewall. Every our workload VPC has a default route 0000 through transit gateway. Packet goes to transit gateway attachment. Transit gateway attachment has appropriate route table associated with it. And here we also have default route zeros to the security VPC. Then traffic goes to security VPCs, to the transit gateway attachment interface, where route tell us that zeros goes to the gateway load balancer. Gateway load balancer automatically forwards a packet to the one of Palo Alto firewalls according to availability zone to avoid cross-zone traffic. Then traffic is analyzed in firewall, and if allowed, it goes back to the load balancer. And here another route table is working, and we have zeros goes to the NAT gateway. And then we goes to the NAT. NAT gateway has zeros goes to the internet gateway, and traffic goes to the internet. Then when traffic comes back, it's the first route table is NAT gateway. And here we have 10.0.0, our internal network used for VPCs, and target is gateway load balancer. From the gateway load balancer, it's again by default goes to firewalls, analyzed on firewall. If allowed, come back to balancer, to the gateway load balancer endpoint. And here a route table says that traffic to 10.0.0 goes back to transit gateway. And this attachment of security VPC in transit gateway has a bigger route table, which has routes to appropriate VPCs, and these routes are automatically propagated. And traffic originated from production VPC returns to production VPC. It's actually how we isolate workloads and how we filter and secure our internet connectivity. And talking about applications for FreeTV, let's split it in two big parts. One part is management application. It's not about streaming itself. It's more about user management, billing, onboarding, CRMs, different APIs. And this part is deployed on several instance families. One is backend, located in private subnets behind internal application load balancer. Then we have autoscaling group for front-end EC2 instances, again located behind application load balancer. And then we have publicly facing CloudFront distribution that use this application load balancer as origin, and users connect to system through CloudFront. CloudFront in this case is protected by WAF. It's AWS managed and our custom rules, and AWS Shield that providing DDoS protection. And before talking about streaming part of the application, let's check a little bit about what is direct connect. Because streaming part contains on-premises servers, and direct connect is a AWS service which allows you to create a dedicated physical connectivity with single mode optic fiber from your data center router to the AWS location. Then your physical connectivity, physical channel can be split to different virtual interfaces. And there are three different interfaces exist in Direct Connect. It's public virtual interface, And through it, you can access publicly available APIs and endpoints like S3, DynamoDB, and CloudFront. That is our case, actually. Then private virtual interface is used to access your VPC's resources. And transit virtual interface is used, again, to access private resources within VPC. But if we have multiple VPCs with transit gateways, maybe multi-region, and here we should implement this connectivity through transit virtual interface. But our part is this top one with public virtual interface and how it looks like actually. We have our on-premises origin servers, two links, 10 gigabytes per second each, created between on-prem data center and direct connect. These links are united into link aggregation group. This is active aggregation group that actually summarize our bandwidth. And in the result, we have 20 gigabytes per second link, and which also increase high availability. And if one of links goes down, we still have another one. Then in direct connect, we create public virtual interface to the CloudFront, because CloudFront is a publicly available service. And then through global network backbone, highly performant AWS network, our video goes to different CloudFront edge locations where users from different countries and continents access our content with low latency. And on this stage, we like an extra security measure is to block some specific countries using a native CloudFront capability of geo restrictions. And about cache hit rate for the streaming, we can see that in average it's between 90 and 95% of hit rate, with some daily short decreasing to 80%. It's exactly time when we add new content to origin servers, and CloudFront needs some time to cache it, and then it just returns content with lower latency from the edge locations the closest to the end user. And about the traffic, it's many petabytes of data going through CloudFront within 1 month. And to summarize, multi-account organization gives control, scalability, and security. Transit gateway and Palo Alto firewalls provide centralized network visibility and compliance. CloudFront with WAF and Shield secure and accelerate content delivery. And Direct Connect ensures high performance and security for the hybrid infrastructure. And if you like to dive deeper, check out the YouTube video of how to configure Palo Alto firewall in AWS. GitHub repository with the solution of network orchestration for AWS Transit Gateway. This solution exists for 6 years and actively developed and maintained. And it's pretty useful for multi-account, multi-VPC orchestration with Transit Gateway, and AWS blog for different deployment models with firewalls, with outbound traffic filtering, inbound traffic filtering, hybrid architectures, and so on. Thank you for your attention. I hope this session gave you practical ideas of how to combine security, automation, and performance for streaming workloads. And I'm happy to take your questions now.
Alexei, thank you so much. I appreciate it. It was really, again, insightful presentation with a lot of knowledge that I'm sure that the audience appreciate. As I mentioned in the chat, and you can see already, the webinar will be extended in a few more minutes, and I sincerely apologize for that. I just want to have at least one more question to be asked, and also share our live draw with you for 100 Amazon gift card. So let's pick, I can see the first question that was asked for you, Alexei, from, I hope I pronounced it well, Andrena. She wrote, great session. What are the best practices for integrating AWS network firewall with existing security group and NACL configurations in a multi-account setup to ensure layered security while minimizing management complexity and overlapping rules?
Okay. So AWS network firewall can work as alternative to our setup. So we use Palo Alto firewalls, but it's just competitors with network firewall. And in case of using network firewall with existing security groups and network ACLs, they are actually independent and they work separately. So when you integrate network firewall, it will have own set of rules, and you still have your existing security groups rules and network ACLs. So they work separately. And if you need some centralized configuration for multi-account, there is a service called Firewall Manager in AWS, where you can set up policies for your organization and manage WAF rules, network firewall rules, security groups centrally for your organization.
All right, Alexei, thank you so much. I think that, although again, I see a lot of questions, but since we already passed our time, please excuse us. And I still want you also to have the ability to win our draw. So with your permission, please, I'm just going to share my screen. And feel free to scan the QR code or join by pin by crowd party the app and put this pin number in order to be part of and start participating our raffle. You can do it right now as we speak in order to actually be part of the raffle. I believe that meanwhile, perhaps we can have at least answer one more question during the time that people will scan this this QR code. So I can see that there is a question from Andre for Yossi. If IP rate limit rules in WAF are considered as DDoS layer protection, how to set and test them properly? Make sure people under NAT/IP translation are not unexpected blocked.
So it's a big question because there are a lot of ways of doing it. So except, I mean, we usually put the IP rate limited as the last rule or the first rule. Depends actually in your overall posture and what is more important to you and what kind of traffic you're trying to protect. So if you're trying to protect against bots, there are packages that are like especially manage good bots versus malicious bots. Will allow some to go through, the right ones to go through while blocking others before even getting to the rate limit rule. So there's a lot of rules. You can, I mean, we have a lot of, we have many security experts that can help you to do that. And of course, Automate-it is here for it as well, having the knowledge to mitigate the rules and put the right rules, and of course not just the rules themselves, but the priority of the rules, which one first and which one later on. There are a lot of blogs about it. So basically, yeah, just consult either Automate-it, AWS experts, or blogs in the community.